Jake, you're gonna be interviewed and be like.
Okay. Okay. Thank you, Jake, for that presentation. And I'm back again. Hopefully for the last time, but we'll see. Yes, today I'm going to talk about Apple and the way it deals with malware. And just like Jake said, presentation, they might do something with Yara rules, so I thought that was pretty cool. Yeah. So, meme of the day. This is I don't know how you guys will think about this, but I was like, okay, it makes sense. As we go on, it just keeps going. There's no end to it until we die.
Is this how you feel right now?
Honestly, yes. I kind of feel like this currently. It's all good though. But on the good side, I thought this was cute. So you guys have to be optimistic now. Yeah, and yeah. And lastly, just want to make sure everyone is doing good. It's like it's the middle of the semester. Everyone is tired. We have a lot of stuff going on. So this is my daily check-in with everyone. I know I can't say to individual, but overall, I hope everyone is doing good. So, okay,
No, Emmanuel, we need to check in on you.
I'm doing fine, honestly. This is what keeps me alive. But yeah, okay, let's start. Apple and malware. Yes. So, first thing, a keyword in the whole macOS system is notarization. It's essentially just stamping like a document or an application saying that you did this to show that it is genuine. Like you know what this is. It's valid, so nothing should be taken as a malware or just anything else. And it is used to, like, if you're trying to upload an application on the App Store or just distribute your application anywhere, you have to do this. If you don't, you get, every time the user tries to download your app and run it, they get this beautiful message saying, hey, macOS cannot detect if this is a malware or not because we cannot verify the developer's signature. So it tells you, are you sure you want to run this? So behind the scenes, it does a lot of magic. I think we'll get to it later on. But for now, if you try to run an application that's not notarized by Apple, you get this message and you can either delete it or just bypass it by telling, like, yeah, there's a way to bypass it. Okay, next slide. So how does it work? Before I actually answer that question, we're just gonna do a little quick updates. In the newer versions of like macOS or the Catalina and the new one, Big Sur, notarization is like you have to do it. Before those two versions, it was like they were still trying to get the whole security stuff going on, so it was not like stamped down. But now you have to do it. You don't. It's not like an option. You have to do it. The only thing is if you're going to upload the application from the App Store, it just doesn't. It does a lot of stuff from there. Like if you write your code on Xcode and compile it from Xcode, it does all that for you, so you don't have to manually do whatever they need you to do. But and also Apple software, they know it's their software, so they don't have to notarize it. I don't know if that's a good or a bad idea, but it depends on who's talking about it. But again, you can really still distribute your application everywhere without being notarized, especially if it's a command line tool. You can really just pass that step. But as you go on, it gets really hard to like really run applications that are not signed or notarized. Like in this case, I downloaded a Chrome driver to use the Python Selenium package. And if you try to run it by just double clicking on it, it tells me this because it wasn't downloaded from the App Store and probably not signed by the developer, which is Google, which is also weird. I just thought about that. Yeah, so I get this message if you download something from the not from the App Store, so like from the internet, it just tells you this. You got this from not the App Store, so are you sure you want to run this? And it just makes sure you know what you're doing. And again, there's sometimes where it doesn't show that, but you also need to explicitly give it permission. So This is the settings app where you have to tell it, oh, I don't care for the security aspect of this application. I just want to run the app. So you can always just go into the settings and just run anyways. So at this point, you're just given, you are in control of what happens after this. Apple cannot help you with this at this part. Yeah, but before the Chrome drivers, as you can see, I couldn't run it directly from like when I double click on it. But if I go to the terminal and I just run it, it actually runs. And I thought that was weird because I thought it was still supposed to stop me from running it. But I don't know if that's a security vulnerability, but yeah, that was weird. So just going back again, to build an application and really publish it to follow Apple's rule, you have to sign it correctly and fully, and you have to do something called hardening the runtime. That I'm not really sure what it is because I've never published an application on app stores, but if you want to know more, that link would really tell you how to do it and stuff like that. So after that step, you have to pack your app or your application. I'm just going to keep going back and forth in a way that's acceptable by the Notarized service, and that's by taking your file and putting it in a DMG file. I'm not going to say that word, and you just have to do it in a bunch of ways that Apple really understands, so they can really verify you are who you say you are. The zip archive. I thought this was fun. Pretty much your whole application, every app you see, the icon, that's just a folder. Just a folder with a different icon to show. Yeah, like the original binary itself, it's located somewhere else inside the folder. It's not the icon itself. I thought that was pretty weird and cool at the same time. Okay, but how does the Notarized service work? First thing it does is it checks if the app is a malware by using something that we'll talk later, but it is exactly what Jake just told us about. It uses some Yahoo rules locally, so that was pretty cool. It does that. I'll get to that later. And if all of that is met, it does some more behind the scenes. It checks, it hashes the binary and sends it to Apple servers and check it with your database. And if it's not there, it adds it to that and just keep it in there just in case you need to run it multiple times. Oh, okay. Whew. Yeah, this is just the steps of how the Notarized service really work. I'm not really going to go in depth into it. But at the end of the day, like I said, Apple is trying to make this much easier for people rather than you manually trying to like get the signature and attach it to your app and sending it again back to the Apple servers. If you do everything from Xcode, it just simplifies that whole step for you. And yeah, so all you have to do now is just keep on writing code because that's what we like to do. So keep doing that while they deal with the security aspect of it. Okay, so let's say you've uploaded your app, yada, yada. You want to run your app. There's two cases. If you download the app from the internet, by default, it's going to add the quarantine tag, as they call it. So it's going to like a 1 or 0 off and on. And if it's on, it's going to be right here. It's going to have the flag apple.com.quarantine. This just tells the Notarized service, or just pretty much the system that says, if you're going to run this, you should quarantine it first to make sure it's not malicious before you can actually run the malware. So the first case is the Chrome driver, which I got from the internet, directly from the internet. And you can see it has the flag. And this is the Trello, which I got directly from the App Store. And as you can see, it does not have the quarantine flag. So that's that. And again, it does the whole Notarized service on the top one. So after that, there's something called the Gatekeeper. As the name suggests, it's like the first step before getting into the, I don't know how to describe this, but like it's the first step of the Apple security, not the security in general, but like just for app security, it's the first step. It checks if the application hash is valid, so it checks it locally and or on the Apple server. So it does all of that and make sure it's valid. So that's if the developer's ID and signature is valid, because again, they can Apple can cancel your, not cancel, what's the word? Yeah, they can revoke your signature. So they have to check that first. So after that, they use something else called the Xprotect. I thought that was a cool ass name. Xprotect is the main part I was really interested in this. It checks if the code or your application is malware by checking it against a list of Java rules, which is cool. So yeah, Java rules. If it's, again, this is what you get. If it's downloaded from the internet, it just tells you, hey, this is from the internet. Are you sure you want to run this? In this case, this is showing the Gatekeeper doing its work right here. So let's say it is the Gatekeeper says the signature is revoked, and if Xprotect says, oh, this is a malware, if those two pass the test or fail the test, I don't know, the process would be stopped, and it's going to just tell you, stop. Are you sure you want to do this? This is definitely a malware. We can delete this for you. Are you sure? It just asks you a lot of time just to make sure you want to do it. And at that point, it's just up to the user. It's a user consent. So if you want malware in your computer, you can have it. If you don't, you don't. Yada, yada. Yeah, this is what you get. It tells you, hey, this is a malicious software. You don't want to run this. Yada, yada again. Yeah, pretty much, this is the wrong image, actually, because if it is a malware, it's going to say move to trash. It does not even give you the option to run it. It just tells you, we're going to move this to the trash because we don't trust it. But again, you can bypass it by just, there's a way to bypass it. I'm not sure I can say that. So a little thing about the only quirks about the whole notarized process is it takes quite some time. It takes a while for it to do all of that checks and now give user consent to that. And it's a whole process. And people have noticed this. It really slows down the time it takes for an application to open and run. And people don't really like that because we are efficient. We want it to run fast, quick. But there is some checks that are cached locally, so they don't have to do that whole step again. And I have actually not come in contact with that. I've never seen that happen. They're still a little bit slow. But overall, the whole process is good, but also slow. They could probably find a faster way to do this, but I cannot think of one at the moment. So let's talk about Gatekeeper. The first step. The Gatekeeper it was introduced like at 2009, I think. It's quite a whole tool, but it's now called the Gatekeeper, and it's a collection of security features designed to keep malicious software from running. So the first step, again, it's the first step, so they don't want the user to really do a lot of work, so they do all of that step, checks and all that stuff by using the Gatekeeper. And this kind of just encapsulate the conflict. I'm going to read directly from the slides on this one. This encapsulate the conflicts between wanting to block everything that's not trusted. So it solves the solution of everything that's not trusted, and it's an open house for malware. So that part I actually thought was funny. So it's just a way to actually collect malware, because they might not be I might be wrong with this, but this is a good way for, I guess, security researchers to get malware if they really want to, because it's going to do all those checks and say, oh, it's wrong, no, it's false, it's dangerous. So in that way, you can just really save that malware if you need to analyze that later. Yeah, so it's pretty much like an open house for any malware that wants to be shared around with developers or security researchers. So there's 4 main steps of the whole Gatekeeper. First, it scans for any evidence of malicious software. It validates the code signature. Again, the main part is the code signature part, and ensures that the application was not messed around with. Again, validates the identity of the software. Pretty much they're all the same, pretty much saying the code or the signature is valid and everything is okay to go. Nothing fancy there. So this is 2 versions before the current one, and this is how the whole app cycle, not the app circle itself, but like the checks really goes on. So if you have the download from the internet, obviously it gets the quarantine flag, and the launch services, this is like running from like from the GUI. So it's called Finder, and it's equivalent to the File Explorer on Windows. So when you double click on it, is that the word? Equivalent. Apparently it's equivalent, but they look. Well, the point is, if you need to visually see where things are located, like the folders, it's called the finders in Mac OS, and that's also called the launch servers. It does that. Then it does some checks, but we're gonna ignore all of this step. We don't need that. Actually, no. This is where the Gatekeeper does this signature checks, and again, if it fails, we get that weird error saying, "Are you sure you want to do this?" Or like it tells you this is the application signature has been revoked, and we don't think you should continue running this. So it does that, but if it's not, if everything is good, it then checks for Xprotect, which is again my kind of favorite part, because it just runs against the Java rules. And again, if it's not a malware, it clears that flag, and everything is all good to go. And then you just go back to running the application the way it's intended to. So this is the way it worked before, but yeah, I pretty much just said everything right there. There is a way to bypass from, I think it was in this version. 1 second. Well, I don't remember anymore, but this is a summary of the picture if you guys want to read this later. So if there's a quarantine flag, it checks with the Gatekeeper and the Xprotect, and finally the user consent. If there's no quarantine flag, it's most likely ran from a location that the launch service is not sure of, and for some reason it bypasses the Xprotect step, so it does not check if it's a malware, but it's still going to check if the signature. It's going to check if the signature is valid. So I thought that was weird. So yeah, that's pretty much how it worked before. Now this is Catalina, the ones before the current updates, and it does a little bit more. It adds more checks. So as you can see at this side, rather than just having like one huge Gatekeeper check, it does a lot. 1 second, I want to double check on something. Okay. This is the image for the Catalina and how it works, the Gatekeeper works. It's much more complex. I'm still trying to understand more of this, so I cannot really give details of how everything works, so yeah. But according to some article I read, the changes are that no matter where, if the application has a quarantine flag or not, it's always going to run the Xprotect. Like this is the first time. So if you first download the application, it doesn't matter if you have the quarantine flag or not, it's always going to run the Xprotect file, because if you remember in the previous version, it just ignores it if the application is ran from a unknown launch location, and it just bypasses the X check. But now everything runs. Yeah, you can read that if you want to. That's too much down. So Xprotect, this is the big part. This is why I did this presentation. This is why I wanted to do this presentation. Xprotect is pretty much, I might be wrong with this. I think it's like the Windows Defender on Windows, only because it checks if the whatever program you have is malware. And it does not delete it. It gives you the option to delete it, it just not delete it. I don't know if that's a good thing or not, but on Windows, as you guys know, it just right away deletes the, yeah, like right away, just like, I don't care, I'm just gonna delete it. macOS though gives you the option if you do want to delete it. So take it as you, that sentence, take it as you want it, I don't know. And okay, the cool part about this is they do have a local list of all of this, they have a local database of the malware they are aware of, and they check locally on your machine, and it's located at that file system. So /system/library/core services/blah blah 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 xprotect.yara. I thought that was cool. So that's where you can find the list of Yara rules they have. Again, obviously, one second. Some of them are public, but I believe most of it are, they just have it privately. Like, I don't know how that works, but like, I'm pretty sure that's not the full list. They probably have more in their servers. So, yeah, what's your question?
If someone were to want to take a look at xprotect.yara that doesn't have a map, where could one find it? Can you send me xprotect.yara?
I can do that. Actually, I do want to share this. I'll share my full screen. I know it's terrible, but no, we're fine. I know you guys can't see because it's really small, but this is the, I found this application called the Xprotect, and it just makes it more visible, UI, but we can just look at the terminal because we're cool like that. Actually, no, that's a lie. This is part of the Yara. No, it's not here. This is the Yara rules. As you can see, I was trying to search for a malware that I knew about, but for some reason, the rules are not here. But just like how Jack has given us the intro of how Yara rules work, we can see they have some of the most known malwares, and yeah, like it has the description of the name of it and the conditions they're looking for. Look at this. This is the X code, just X, right? X, yeah. It's a long day. Yeah, so they just have this locally on your machine, but I don't think you can change it, which is it's locked. Like, I'll show you. It's if you go. So if you like Vim it shows you that little thing right there saying you say you can't change it, but you do whatever you want. I'm pretty sure you can. The application I have right here gives me the option to add more rules, so maybe you can, maybe you cannot. I didn't try because I don't know Java rules, so, and I don't want to mess with the ones they have. Yeah, so I thought that the whole thing was cool. And it's pretty much hidden from everyone because the Gatekeeper is what you see, but the whole Xprotect is behind the scenes. You have no clue. I had no clue until like a week ago. Yeah, so the way I see it is Gatekeeper first, checks signatures and all that stuff. If everything is good, then the next step is Xprotect. Yeah, what else? Yeah, again, I was trying to make this presentation as long as possible, but this is like the easiest part of this whole process. It's just literally checking the list, and if it's there, it tells you it's going to delete it, but it's going to give you the option to delete it. If it's not, then it just keeps on going. So, yeah, I couldn't make this as long. It just checks against the rule. We tried. So the whole process, is it really good? According to this article, it's useful, but it's not the best. Yeah, that was the whole thing. The type of malware you get on macOS is usually Trojan. You just get a legitimate application, and for some reason, the most Well,
That's probably the cyber yeah.
oh, it says it's shutting down.
What?
It says please wait while the system shuts down.
The mic audio, is the mic audio, okay, the mic audio is good. You're good to keep going.
Okay. Yeah, and it says like on like the other anti virus application, it does not use, it doesn't do some advanced checks. But I feel like they do, but just obviously we do not know about this. But because it's Apple being Apple, we love them for that. Well, I do, but most of you don't. Yeah. Yeah, and it's kind of weird because this is like a list, like a static list for us. We just, I don't know. I feel like it should have been more. You